if in your module it is combined with the next chapter, but I thought to go for next chapter will be too long. So I just focus on the one hot encoding, and it's also used for your lab. So are you here, everyone? Tekpal, you still here?
Okay, I'm here.
I just continue. Yeah, I don't wait. So they can check the recording after this. Right, a one hot encoding. So far, what we use is only the binary coding, right? And also in the binary coding, sometimes we use gray coding. Gray coding is when you use S0 for 00, S1 for 01, S2 11, and S3 00 or 10. Like you use gray code coding, and usually the gray code somehow is much better in terms of the circuit. Yeah. Because if you notice, K-map is also based on gray coding because it's a minimum change code. Now, um, let's go to the next slide. Okay. Now, what is one hot encoding? The, the terms one hot is actually, it means only one flip-flop out of many will be activated or triggered or logic 1. The rest is 0. I mean, the state of the logic. You can never have two state active at any time using one hot method. And for that reason, uh, one state require one flip-flop. So if you have 8 states, if in binary, straight binary, you just use 3 flip-flop. However, if you use one hot method encoding, you need 8 flip-flop because one state, one flip-flop. So only one flip-flop high for any given state, and it looks like you are wasting because, for example, if for 8 states using binary coding, you just need 3 flip-flop. However, if you use one hot, you require 8. So the additional of how many now? 3, 5, extra 5. However, in our finite state machine design or our design digital systems, we are assuming we no longer use discrete component like multiplexer, decoder per se or digital logic per se. What we use is FPGA, CPLD, like everything integrated field programmable gate arrays whereby you have many flip-flops already integrated into one chip. So therefore, if you use 3 or if you 8 or if you 100 flip-flop, still you use this one chip, this one FPGA chip. So the cost is basically, in terms of money, is the same cost, maybe in terms of complexity. But then we will go how we simplify the one hot method. Eh? Now, for example, this vending machine which we discussed before, if you use binary coding, you will use, this is just for comparison. If you use binary coding, binary, or you say straight binary, you will use here 4 state, maybe you use 0, 0, 0, 1, and 1, 0, and 1, 1. And because you have 2 bits, therefore you require only 2 flip flop. However, if you use one hot encoding, you have to use this method 0001, 010, and 1 and 1. Meaning S0 is named as 0001, S5 0010, and so on. So now you require 4 flip-flop. It's like you double. But there is a good news about it. It's very fast. You don't need a K-map. And one hot method is actually suitable when you combine your number of bits or number of flip-flop plus number of inputs if it's more than 4, because up to 4 bits you can still doing simplification using K-map to get the equations. But if it's more than that, definitely you have to go to this alternative and use one hot method. So how you do it? You use this concept. The S0 prime, S0 plus, S0 plus, S0 plus. Previously in binary coding, right, in binary coding. For example, if it's 2 bits, right, you use symbol of Q1, Q0, and for the present state, right? And for the next state, you name it as Q1 plus Q0 plus, right? But for the one hot, this is the one hot one, the approach is different. We use the state name because um, the approach is based on the state. Okay, so if you have the state as 0, so this is present state, so the next state will be as 0 plus. So the plus symbol identify for your next state because basically these are the same point. And then the first incoming state, for example, S0, and this is the input condition, right? And the second coming state. So let's do, although I have the solution, but let's try to do it here. So for example, what is S0 plus? Okay, there is an answer after this, but let's try. I'll show you the process. So for the S0 here, how do you get the S0 plus? You look at how many coming in. And in fact, if you see here, you have one reset. You can just input in to complete the story here or to complete the equation. You have one line coming in from reset. When you will have one coming from the SO itself. And what is the condition? D bar N bar. So you have D bar and N bar, right? And the third arrow coming in this one. So the third one is from S15. Okay, S15. And the one here means unconditional. Unconditional, meaning it just unconditional, meaning just S5, S15. Mean once you come to this S15, by default, coming pulse, it goes straight. So either you put one or you don't put anything, also can. The one here means it always true, or it also, if you don't put this value, also it knows that. So you have 1, 2, 3. So that's when you 1, 2, 3. Now let's start from S5. Example, S5 plus. Next state for S5. What is the next state of S5? Now S5 receive the first one is from here. So where is it? It's coming from S0 with the input of N. So that means S0 N. Okay? Plus. What other alternative? This wire. Right. This one. So that means from itself, which is S5. And the input condition is D bar N bar. D bar N bar. Anything else? Only 2 wires, right? So that's all. That's it for S5 plus. Now for about S10 plus. S10 plus, you have 1, 2, 3. 1, 2, 3. So you have to have 3 product term. The first one is from S5. Okay. The condition with N, if N is true, or the input is N. The second one is coming from itself, which is S10. Okay. And if the condition is D bar N bar, so you put D bar N bar. And the third wire coming in, or the transition, is this one, which is from S0. And the condition is D. So that is the equation for S0 plus. And finally, you want to do the S15. Where is my space here? For example, I am a bit messy here. Yeah? So S15, let's say, try to put here. S15 plus is equal to what? You have one here from S5. Or you can take here from S10. S10. And what? N or D. So you can do N or D. But actually, there's 2 arrow coming from top, S10N or S10D. This one, that's what it means by here. And plus, what else here? S5D. S5D. Right? So you're done. You're done with the next state. And this next state, all this one is flip-flop input. This one is the S0, S0 plus, the S5 plus, and the S10 plus. How many there? S15 plus. These are all flip-flop input. Flip-flop inputs. Yeah, same as before. Next state is actually your flip-flop inputs. Next, what is your output? You have only one output, so that means you have this one is more output. More output. You simply say you have R is equal to S15. In fact, you actually can have a mixed. That means you can have more output and milli output. Actually, also can. So this is how you come up with the equation. And this is a presentable. I think it will be okay. It's the same thing, right? So if you look at this one, S0 d bar n bar, which is this one, plus S15, yeah, with no condition. And that is again this one for the S0, for the S5. That's what I did before. So you have the S0n is coming from here to here. That's one. And then you also have one more S5 from itself, loop back to the n, d bar n bar, and so on. So what it means is that you skip. You don't need the truth table. So that's why actually this topic has to be postponed to the end. So why? If we started with this topic, you don't want to do the K-map anymore. You don't want the binary coding. Binary looks simple, but what happened? From the state diagram, if you use the binary method, what is the process? If you use binary coding, from the state diagram, you have to do the state table, right? A state table. And then from the state table, you do the K-map to get, to obtain the next state, equations, and the output. So for example, if you have 3 bit, so you have 3 K-map and 1 output or 2 output, 2 output. So, and then only you draw the circuit. But here, from state, you go straight to this point, and then from here, you already got the circuit or the FSM, right? So how does the FSM look like? Try to remember this slide. Now, this one, okay? So these are all the equations. Now, this is also the way you should do for your simulation. Don't loop back, but you have to label. You have to label all this thing properly so that you can use it here. Yeah. Now the only thing, notice the red color here. You have to specialize this part. Yeah. This one is actually to force. This is to force. 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 Force reset. That means you force reset so that starting before the clock, this will be 1, this will be 0, this will be 0, this will be 0. This is what this guy doing. Yeah, this reset has to be there, and this has to be preset. So got 1 and this one. So this is the first approach to force your state diagram to start from 1, 0, 0, 0, or if you read it the other way around, 0, 0, 0, 1. Okay. Now the second method, you can also this is the reset. So reset is actually active low just now because this is asynchronous. These are asynchronous input, and this one active low. That means you provide only a pulse, a low pulse for momentarily. So therefore, you can use a push button, right? What happened here? If you press the, if you don't do with the button, right? It will give you reset of VCC. That means under normal condition, your output will always be high, which is what you want. But once you press this button, it will give you the low, and then when you release, it will go to 1 all the time. So you just want to do this one only once, like a start, like a starting, eh? To start the FSM, all right? Alternatively, what you can do is you can also add this inverter, also this is like cheating a bit. You add because if you use quarters, initially it will start from 0, 0, 0, 0. This is the default of the simulation, and normally the circuit is also starting from all zeros. However, if you remember one hot, you don't have the all zero state. So what you want to start with 0, 0, 1. That's why the lowest, the L0 plus, you put inverter so that here we are in your design. This is in your design. This is actually will be 0, but you have the inverter so that you will start from 1 and 0 and 0 and 0. Or actually, this is to ensure if you have the state of 0, 0, 0, 0, that will never occur. It will always give you, instead of 0, 0, 0, 0, it will give you a 0, 0, 0, 1. This is another way. And for your digital lab, you can do this one as well. So in this case, actually, uh, you don't you don't need this reset. And this reset is actually a few ways to do the reset. Okay, the mechanism of the reset can be, this is the first mechanism with this preset button. This is the second method, yeah, where you put inverter to start, you invert to give the 0, 0, 0, 1 starting. Or another one is you go use ghost. It says ghost state. This one, yeah. So this one is actually meaning your kind of is one clock delay only, one clock delay, yeah, in your system, because upon reset, let's say if you have this reset button, it will go to the 0, 0, 0 set or 0 state, but without any condition, it will go to the 0, 0, 0, 1 state. And then it goes to 0, 0, 1, 0 and 0. This one only 3. I shouldn't use I don't have to use 4 bits, right? I just use this is wrong. This is wrong. This is only 3 bits. Mistake there. So what it means is the init is the 0. Why my 0 coming? This one is 0, 0. But after clock coming, it will jump to 0, 0, 1, and then it will follow the one hot method, 0, 1, 0 and 1, 0, 0. And this one only one time, only the beginning, and then it never go back to this part. That's why dotted, meaning this one, the state is just to initiate. Yeah. Uh, all zero state detected. No, if you detect that 0, it will push to the, this is the design state. Yeah. So usually no effect on FSM. Um, if you really thoroughly study the waveform, you can only see from the beginning, the first clock, you you need one clock before you go to the process or the operation. Okay. So init initialization 0. So what happened is that this init, how you realize this is the init, but the init is simply this one. This is the init part. You just put the XNOR, meaning if this is 0, this is 0, this is 0, right? It will give what? If you got from state 0, 0, 0, it'll be 1, right? This one, it'll be 1. If this 1, 1, 1, no, this one is just to get the 1. So you use the NOR gate. You use the NOR gate. NOR gate, the output is low if any of the input is high. Sorry, output is low if any of the input is high. Output will be high if all input low, right? Whatever it is. But this one is the initial one. And then you have the release and the rest. So this is another method. So actually, with this method, you don't really need this one. This one actually you don't really need, but probably you can just say this is a start button. Or you can, if you don't do this one, If you don't do, also can do away also. You can do away with this. This one is reset. Now, if you look at the reset, it go to 0, 0, 0. That means you start from 0 rather than 1. But that will force to start here to be 1, 0, 0 due to this init. Yeah. So the next equation will be, this is examples only. This is example to show, that's it. Finish. This one actually I don't have to show you. This is one of the traffic light system. I forgot to delete this part. So I think it's enough until here. So you have three options to modify your one hot. One is here. Use one. I used to do this way actually. I like to use that method actually. Okay. All right. That's all for the second slide. So I told you it's going to be short. So let me stop the recording. So if you look at the recording, it won't be very long. Okay. So now you know the one hot method. So for your test, just to inform you, they're going to be test on the 19th, which is Tuesday after next Tuesday, right? So as I told you in the group, prepare, if you're not familiar with cam scanner, please download the app so that, because that cam scanner, the picture is very nice. You can, what is it? You can snap and combine. It enhance your picture. If you just take the JPEG picture from your camera, phone camera, it will be difficult. But if you have printer, it will be better. And then there are going to be a few sets of questions. So to differentiate, I will make a suggestion in the instruction for you to include the first questions of your test paper, but the rest don't need. The rest is your script in one file, PDF file. Okay, so now Mahfuzul is here. I'm not sure about this morning. So that's all on this lecture. How much time do we have? It's 12:39. Do you want to continue with the solutions of your exercise? No, basically your tests cover the assignment that I gave you before on register, and also the assignment, the new assignment, which is on the chapter 9, 10, 11, right? The one that is currently. So this topic, the two topic that I gave you, it's not covered in the test two. However, you use it in your, you definitely need to use it in your lab if you're doing your lab. Okay. All right. That's all for now. Is there any question from you? Okay. I will start. Okay. I will. That's all. Okay, guys. Are you still with me? Do you follow me?
Yes,
You're
yes,
not
yes.
sleeping. Okay. Ending the. Shall we just on Sunday we still have time, right? Before the test, Sunday and Tuesday next week, right?
Yes.
Yes.
So we just continue the discussion on Sunday. Yeah. If you want to study much earlier, you want to ask me anything on the assignment, and these two assignment, actually the best way to learn is by doing simulation. I tell you, discuss simulation. Otherwise, you get confused. Is it right? Is it wrong? Is it right? Is it wrong? Okay. But if you do simulation, that will be clear. Okay. So I think the test, inshallah, the test is going to be 4 questions. Basically cover topic, the registers topic, cover the topic on what? Sequential design, one on the sequential design or FSM design, and then one on the FSM analysis, and one more on design as well. So two on design, two on analysis. Okay, so there are going to be 4 questions. So some of the questions are 20 marks. Some of the question, I think the design part, most of them are 30 point. 30, 30 is 60. And the analysis part is 20, 20, that's 40. So we will mark out of 100. 100 point for your test too. Okay? So I think what we'll do is we will give you extra time for you to download the question, but the question will be in password. We have the password. But like on the dot, I will announce you the password, and but you already download. So there should be. So if any of you have problem with the internet, the reason is to reduce your internet problem. So no issue that some of you start earlier because your internet is good, or some students start later because taking time to download the question. So I will let all of us will let you download the question earlier, but it will be password. So I will give you the password right through WhatsApp from no, sorry, not WhatsApp, from our Telegram group. We give you the password, and then you will do. But I think the test is going to be 1 hour and 15 minutes or just 1 hour. So I think I will keep the group live. But if you want to talk to me, only via voice, because I don't want other students to get distracted reading your questions, because you are asking me, and I will try to also turn on Webex, but personal, meaning your chat only with me. Your chat is only with me. That means you can also. So I will sort of monitoring you through Webex and through Telegram. So I will stay alert. You can ask me during the test as well. Don't ask your friend. Ask me. Okay. Right. So that's all. Any more questions? Right. So you clear. You prepare all the papers and please write nicely. If you use pencil, make it clear. Okay. Um, we still have anyone here? I'm just talking to myself. Is it? Oh, I'm still here.
I'm here. I'm here.
Okay. So this is what I have to answer in my comment. I say engagement. No, you actually in one of the lecturer, she stopped doing live because no engagement. That means no student asking any question. Therefore, she opt for the recording. Do you prefer if I just record and share with you recording, or just go live like this? Hmm? I think I just go live. If some of you could not go live, I will share you the live session as in the class session. So don't worry if your internet is slow. You still have the recording, because after all, your friend didn't ask any question anyway, right? But it's better lah if you ask something, because otherwise I feel like I'm talking to myself. Nobody says anything. I don't know why. Why don't you ask anything? Everything very very clear. Hmm?
Oh,
Guy, you don't
clear,
ask me
clear.
anything, is it? Because all right. Anyway, that's all for today. I think I will continue with the QA from the assignment. Make it next time lah, yeah. On Sunday. If you want to ask me because like you have burden desire to find out the answer, because you have done early exercise, it's okay. You can ask me, right? On individual, not group.
Doctor,
Okay. Yes.
hello.
Yes.
Doctor, we will we have a three test?
No, we have only two tests. No
Oh,
three.
okay. Because
Okay.
like if you take a three test, then you can take the best two.
I
That's
know
that one.
before we do that, but there
Yeah.
are theory on the EAC saying that it's a bit not fair to give three. So this time, I think since last session and this session, there's no more three tests, only two tests. Even in
Okay.
my other subject, digital electronics, I have only two tests. No three tests anymore. Okay.
Okay, doctor. No
All
problem.
right. Bye. I'm leaving the test. I'm leaving. Yeah.
Okay.
Stop sharing and